Hi everybody, we are expected to solve a cubed positive a squared is equal to 36. Now just visualize this in this form, x cubed positive x squared is equal to 36. Now clearly we would like to know the number of solutions that this equation can produce. Now in all fairness, if you were to examine x to the power of 3, x to the power of 3 is strictly increasing, right? This is a strictly increasing function, and x squared is also strictly increasing. Now on the right hand side you got a constant function. Now you have two increasing functions, and on the right hand side you got a constant function. Now the only possibility that the left hand side will be equal to right hand side is at one point. So we can specify it as at one real point. So you only have one real solution. Only have one real solution. So I have given you the reason why it only has one real solution. Now having mentioned this, let me just go and solve this. So I'm taking it as a cubed positive a squared. I'm moving 36 to the left, so I get it like this. Then I wish to split 36 as 27 and 9. Then I would like to club a cubed with 27 and a squared with negative 9. So I get something of this fashion. Now this is nothing but a cubed negative b cubed, which is nothing but a minus b, a squared positive ab positive b squared. So a cubed negative 27, I'm going to rewrite it as in this fashion. So this is going to be a negative 3 of a squared positive 3 times a positive 9. So just take this and substitute it here. If you were to take this as 2, therefore 2 can be rewritten as a negative 3 times a squared positive 3a positive 9, and a squared negative 9 is nothing but a squared negative 3 squared, which can be written as a negative 3 times a positive 3. That's exactly what I'm going to do, a negative 3 times a positive 3. On the right hand side I got 0. Now a negative 3 is common. I can take it out. So I get a squared positive 3a positive 9 positive a positive 3 is equal to 0. Now I can write a squared, 3a added with a would give me 4a, 9 added with 3 would give me 12. Now I get a negative 3 is equal to 0. So from here I can clearly write a is equal to 3. It means a minus 3 is equal to 0. So this would mean that a is equal to 3. This is the only real solution, as I mentioned to you. Now on the other hand, you got a squared positive 4a positive 12 is equal to 0. I wish to write this as a squared positive 4a positive 4 positive 8 is equal to 0. Let me move a to the other side. So you get a squared positive 4a positive 4 is equal to negative 8. I can rewrite this as a positive 2 raised to the power of 2. When you expand it, you get a squared and then 4a positive 4. That's perfectly fine. Now from complex numbers, I got I squared is equal to negative 1. So let me rewrite this quantity as positive 8 times I squared, right? Because of this fact, I squared is equal to negative 1. Now this is nothing but a positive 2 is equal to root of 8i squared. Now root of I squared will give me two values, right? So for the time being, let me just hold on to this like this in this fashion. So from here I get a is equal to, let me move the 2 to the other side. So you get negative 2. From here I would get positive I times root of 8. This will be one value. The other value would be a is equal to negative 2 negative I times root of 8. Of course you can, if you want to write this, you can very well write this as negative 2 plus, this can be written as 4 times 2, right? So it's going to be I times 2 times root 2, and this can be written as negative 2 times negative I times 2 times root 2. So to sum up, the final solution, what are the final solution? I got one real root, and then other things are all complex. So negative 2 negative I times 2 root 2, and then you got negative 2 positive I times 2 root 2. So that is the end of this particular question. Thank you.